Good afternoon, this is Ms. Parks, and today we're going to talk about properties of logarithms. And remember that logarithms are very closely related to exponents. They kind of behave in the same way. So we have the product property, quotient property, and the power property. I don't care that you know the names, just understand how to use them. Now, if we had, let's say, x to the third times x to the fifth, that would equal x to the eighth. Okay, because if you add those together, so I'm going to reverse this, x to the eighth equals x to the third times x to the fifth, because it's x to the 3 plus 5. So if I had log, let's say base 2 of, I'm going to say 8x, that would equal log base 2 of 8 plus log base 2 of x. So if two things are multiplied together, you can separate them out and add them together as two separate logarithms. Now, if I had x to the fifth divided by x to the third, I would do x to the 5 minus 3, which is x squared. So if I have log base 7 of x divided by y, then it's log base 7 of x minus log base 7 of y. So division now becomes subtraction. And then the last thing you need to know is if you have a power to a power, so I don't know, let's say log base 6 of x squared, then it's like having, let me just say, I don't know, x squared to the 6th power, you would do x2 times 6, which is x to the 12th. So if you have an exponent, it gets multiplied by the log. Because remember, the log is kind of like an exponent. So this becomes 2 times log base 6 of x. So we're going to do that here. And the reason we need to know how to expand, this is the expanded part. And this is the, okay, so all the ones on this side are condensed. And all the ones on this side are expanded. And in order to solve some equations, you need to be able to do both. So here we go. So I'm going to do this one, and you'll do this one. So this is a natural log, and you have a 5, you have an x, you have an exponent, and then you have a y. So all three things deserve a natural log. You can do this all in one step. I'm going to do it in 2 steps for the first time. So 5 gets its own logarithm, x to the 7th, and because y, anything in the denominator is going to be a subtraction. So natural log of 5 plus natural log of x to the 7th minus natural log of y. However, we can't leave that. So the exponent has to get multiplied in front of the logarithm. Okay, so natural log of 5 plus 7 natural log of x minus the natural log of y. So go ahead and try this one. You should pause the video while you're doing it and come back and play it. Okay, here we go. Natural log of 3 plus the natural log. Actually, I'm just going to go ahead and do this in one step. 5 natural log of x minus the natural log of y. All right, for the next part, we're going to put them back together. We're going to condense them. So when you're condensing logarithms, your final answer is going to have one single log in it. You're not going to have a log divided by a log or another log multiplied or anything. Just one single logarithm. These are all log base 10. The 10 isn't there. You're not going to write it. When we condense, we put everything into one fraction, assuming that you have addition and subtraction, okay? So I'm going to go ahead and put a fraction bar. So we have the 9. We have the 3 log of 2. So the 3 becomes the exponent of the 2. And because that's a plus sign, it's at the top. So it becomes 2 to the 3rd. Okay, we put the exponent back. Minus log of 3 means that this number goes in the denominator because there's a minus sign. Okay, so anything that's preceded by a negative sign will go in the denominator. Anything that's preceded by a plus sign will go in the numerator. So now I'm going to simplify this. 9 times 8 over 3, 72 over 3. So final answer, log of 24, and that is log base 10. Next one, try this one. Actually, go ahead and do the next 5. Pause the video, and then when you're finished, please come back and play it. All right, here we go. There's addition and subtraction. This one will go in the denominator. We've already written the word log once, so we don't have to write it anymore. 6. Be careful that you know that it's not 4 to the third, it's 3 to the fourth. The 4 becomes the exponent. This 3 goes to the denominator. So 6 times 81 over 3, which is 162. Next one, we will expand this. And yes, you have to write log base 6 every time. So log base 6 of 3 plus 4 log base 6 of x. The 3 and the x are separate from each other. Okay, so this means we need 2 logarithms. This one's going to mean we need 1, 2, 3 logarithms. So natural log of 5 minus the natural log of 12, and then minus natural log of x. Now you might get confused on this one because it is 12 times x. So some of you might have thought it was natural log minus natural log of 12 plus natural log of x, which it is if you put parentheses around those because they're both in the denominator. I just think that if you see something in the denominator, there needs to be a minus sign in front of it. If you see something in the denominator, like the x, there needs to be a minus sign in front of it, and then that'll solve everything. Anything in the denominator will have a minus sign preceding it. This is accurate too, as long as there's parentheses, but I prefer the second way. Here we're going to stick all these together. This one's a lot, but you only have to write the log base 7 once. There's addition and subtraction. So these two are preceded by a plus sign. That means they're both going to be at the top. Okay, so we have an 8. And we have that 2 will become the exponent, so we have a 3 squared. These two will be in the denominator. Okay, so in the denominator, this 3 is the exponent of that 5. And this 1/2 is the exponent of 16. So I have 8 times 9, 125 times, that's the square root of 16. So 72, and then 125 times the square root of 16, which is 4. If you reduce that, you get 18 over 25, over 125, I mean. So final answer is log base 7 of 18 over 125. When you can reduce this here, because 4 goes into 72. If you rewrote this as 8 times 9, 4 goes into 8 twice. Okay, and then you have 18 over 125. For this last one here, or this last one of this group, we have addition and subtraction. So we have 4, 3 to the third, and 12 on the bottom. I'm going to write this like this, 3 to the third, and then 12, I'm going to write that as 4 times 3. So that's 9. If you wanted to do this as 4 times 27 divided by 12, that's fine. Final answer, natural log of 9. All right, so we talked about special logarithms already. The common log, which is just, these are the ones that are on your calculator. Okay, so common log is the one that has a base 10 because every logarithm has a base. So when it's not written, it's understood to either be 10 or e. So the way that you can figure out is a log button. Just a reminder, the log button on your calculator usually has a 10 to the x above it. That's the base. The natural log button on your calculator usually has an e to the x above it. That's its base. So if you ever forget what the base is of either log or natural log, just look at the button right above it, and that's its base. So when you put this in your calculator, you can probably do this one without a calculator, but you could just put, because you're looking for 10 to some power gives you 100, you should get 2. If you put that in your calculator, you will get negative 0.071. Natural log of 33, you're going to get 3.497. And then natural log of 0.3, you're going to get negative 1.204. Now, for most calculators, you can't do log of different bases. And so there are a few calculators where you can put in the bases. But we're going to be using something called the change of base formula. It is super easy to use, but for some reason, it's very easy for people to forget. I'm not sure why, but it happens all the time. So when we first started logarithms, I remember I told you that if you have 2 to the x is equal to 6, that you can solve it by doing log of 6 divided by log of 2. We haven't really gotten how to get there yet, but what I want you to know is that log base 2 of 30, to find that answer, you're basically saying log base 2 of 30, I'm going to make that equal x. So if I do the wheel, you're saying x to some power, or excuse me, 2 to some power is equal to 30. And so if I do 2 to the 5th, that's 32. So this answer makes sense. Now we're going to be using something called the change of base. And the reason we use a change of base formula is because our calculators allow us to use logarithms, common logs, and natural logs. So all you have to do is you take this one logarithm and you change it into 2 logarithms. These 2 logarithms will have the same base. It'll either be both base 10 or both of them will be base e, which is natural log. And you just make sure that you do log of the bigger number at the top and then log of the base at the bottom, but you're not really using that as its base. So you're doing log. So you can do log of 9 divided by natural log of, or log of 3, or vice versa. So let's go ahead and do this. And once you see the work, you'll see how it goes. So I'll show you both methods. So you can write here log of 8 divided by log of 3 if you prefer. And yes, I want you to write the formula before the answer. These are exactly, you're going to give you exactly the same answer. Sometimes I write this one, even though putting them in the calculator takes just the same amount of work. This one's a little bit faster to write, in my opinion. So they both give you the same answer. So you get 1.893. Okay, so using this one, log of 11 divided by log of 7. So you get 1.232. Go ahead and do the next. Well, actually, the rest of the problems are almost done with this section already. Pretty quick. So go ahead and use a change of base formula. You can use log or natural log. It actually says to use natural log here. But use whichever ones you want. I don't really care. All right, so after pausing it and doing all these, natural log of 24 over natural log of 6. Natural log of 19, natural log of 2. This one, log of 8 divided by log of 5. Natural log of 14, natural log of 8. You can use natural log or log, it doesn't matter. Log of 9, log of 26. And then for the last one, you should get 1.369. So hopefully this section seemed easier. You have to use your calculator a lot, and that covers section 5.4.